scientists have one mission: to help unravel the secrets of the universe. Whether they're looking for new types of life at the bottom of the ocean, or if they are combining new chemicals and elements to make fascinating new materials, they're all trying to uncover the secrets of our universe. And each scientist has their own special tools and equipment that they use to help them unravel these mysteries. But we think that there might be just one tool that is the most important of all. One tool that has allowed us to discover more than any other. It is the telescope. Today we're going to be learning about these fascinating instruments, how they work, what their history is, and what we can see with them in today's world. Welcome to another Little House of Science video. My name's Ollie, and today we're going to get into fascinating telescopes. The story of telescopes begins in the year 1608, when the first ever telescope was created by a pair of people who ran a spectacle making company. They were making fancy new eyeglasses and experimenting with different types of lens. Lenses are curved pieces of glass that take in a light beam and focus it, essentially allowing the light to be magnified. With a little bit of experimentation, they discovered that they could arrange different types of lens inside of a tube to make the first type of telescope. Sadly, these early telescopes were not used for anything other than scanning the horizon for distant objects, and they were known as spyglasses. One of these spyglasses was bought by one Galileo Galilei, a famous Italian thinker and tinkerer who added extra lenses to his simple spyglass and was the first person to turn it up skywards to look at things in space. Galileo made amazing detailed drawings of the moon and even discovered for the first time moons of other planets. Io, Europa, Ganymede and Callisto came to be known as the Galilean moons of Jupiter. But his investigation of the solar system didn't stop there. In his time, people thought that the Earth was the centre of the solar system. In fact, they believed the Earth was the centre of the entire universe. They believed the solar system looked something like this. The Earth in the middle, orbited by the Moon, and then Venus, and then Mercury, then the Sun, and behind the Sun were the other planets, Jupiter and Saturn. Uranus and Neptune had yet to be discovered, and they believed the outer limits of this system were where we'd find the rest of the stars, and they didn't really understand at the time what these little pricks of light in the night sky were. Galileo's model was revolutionarily different. He, after observing the different planets, noticed, particularly by looking at the planet Venus, that it actually would for periods of time disappear behind the Sun before re-emerging again, showing that Venus definitely was on the other side, at least at times, to the Sun. When he put his observations together, he decided to place the Sun in its rightful place right in the middle of our solar system, with all the planets orbiting in the correct orders. This was known as the heliocentric view. Helios coming from the Greek word for sun, and centric meaning in the middle. So sun in the middle. And this was his revolutionary idea, and he discovered this all with this fantastic instrument, the telescope. Galileo's telescope was a refracting telescope. The curved lens bends the light to focus it, magnifying the image. Here is a real refracting telescope. It has a huge lens at one end, a little mirror down here that pushes the image up into the eyepiece. This here is a little viewing scope. You can use this to help you to see in more detail what you're aiming your telescope at. Telescopes like this are fantastic for moon gazing and looking at the other planets of our solar system. However, they have a major drawback. Refracting lenses bend light, but they can also scatter it out, creating lots of little rainbows around your image. These are really nice and pretty to look at first, but after a while they can become quite irritating, and they're known as chromatic aberrations. These little halo, this little haze of rainbows around your images. Isaac Newton, who was actually born in the year that Galileo died, 1642, was an amazing scientist who discovered a great many things about our universe. And he also managed to solve this problem of chromatic aberration in telescopes by creating his own brand new design. It was known as the reflecting rather than refracting telescope, because instead of a huge lens, it used a huge curved mirror. The mirror would also be able to focus the light, but as it was simply reflecting rather than refracting, it didn't cause those rainbow aberrations, and it allowed for a much clearer image. These telescopes allowed us to peer deeper into space with a lot more clarity. These telescopes helped us to see further than ever, but believe it or not, they were still only letting us see the universe through a narrow window, the small range of light that human eyes can detect. This is known as the visible spectrum, or the colours of the rainbow. Stars and other weird and wonderful objects in space produce or reflect more than just light in the visible spectrum. The full range of light is known as the electromagnetic spectrum, and it ranges from high-energy gamma rays to X-rays, ultraviolet, our visible spectrum, into infrared, microwaves, and radio waves. Light travels as a wave, and as we go through the electromagnetic spectrum, from gamma rays to radio waves, the wavelength gets bigger. Gamma rays have wavelengths so short that they can pass right through individual atoms, whereas radio waves at the other end of the spectrum have waves so huge that they can measure over 100 meters in size. Although the energy of all the different types of light can vary, all of them travel at the same speed through space. To detect these new types of light that are invisible to our eyes, we need special telescopes that are attuned to each chunk of the electromagnetic spectrum. Some parts of the electromagnetic spectrum can travel right through our atmosphere with virtually no hindrance at all, allowing us to build amazing telescopes right here on the surface of the Earth. Nice and easy. So visible light, of course, travels pretty well through our atmosphere, but there is some distortion. As visible light from outer space comes through our atmosphere, it will pass through areas of the atmosphere that are warmer and areas that are colder, and this means the density of that air is slightly different. And this will slow and change the light's path as it moves, giving the image you get a little bit of distortion and blurriness, which isn't so useful if you're trying to look at things that are millions of light years away in great detail. However, radio waves are perfect for looking for down here on the surface of the Earth, because our atmosphere is completely transparent to radio waves. We can pick them up all across the surface of the Earth. Some of the largest telescopes ever built are in fact radio telescopes, and the largest one is about 500 meters across. Incredible. But to see other parts of the electromagnetic spectrum, we need to find a way to get away from the atmosphere. The atmosphere is completely opaque to various parts of the electromagnetic spectrum, including gamma rays and X-rays. So in order to see this light, we need to get past the atmosphere, find a place somewhere where there is no atmosphere in the way. And of course, that means going into space. So what do we need to do? If we want to see the whole electromagnetic spectrum, we need to build space telescopes. NASA's Chandra telescope looks for X-rays. The Compton telescope would look for gamma rays and X-rays. Spitzer telescope used to look for infrared light, and the Hubble telescope looks for light in the visible spectrum. These four great observatories, as they were known, could peer into deep space, giving us glimpses of stars and galaxies that are far, far away from us. The light they detect has been traveling to us for thousands to millions of years, meaning that the light that we received is ancient light. It's light from the universe as it was far back in history. So for this reason, we can think of space telescopes as a little mini time machine, able to peer back into the very earliest origins of our universe. Perhaps the most advanced telescope of all time, the James Webb Telescope, which was recently launched, is purpose-built for looking at that first light of our universe. It is able to detect light that is 13 billion years old, and it can see the first galaxies that were ever created in the universe. This can help us learn a great deal about our universe as a whole, and it can even help us learn about what the universe's future might have in store for us. The James Webb Telescope, in order to take these images, has to be quite a long way away from the Earth. In fact, they've placed it 1.5 million kilometers away. It's not just built for looking at ancient light. It also has special cameras that can detect beautiful images of more close objects, such as amazing nebulas and other incredible objects in our very own galaxy. It can even, possibly most interestingly, peer into the atmospheres of distant exoplanets. Those are planets that belong to other solar systems, and possibly one day it might discover signs of life on another planet. It's possibly one of the most incredible achievements of modern science. I hope you enjoyed this video all about amazing telescopes. Do join us again for more videos in the future. My name's Ollie, and I hope to see you again soon. Thanks so much for watching, and I'll see you next time.